Welcome everyone. In this video we will find the indefinite integral of cosine of x raised to the power of 4 dx, of course. How can we approach this question? To start, I will first write the integral sign one more time, and then we will have cosine squared x, all of that squared dx. This is going to be equal to, now what could I substitute for cosine squared x? The first thing that comes to mind is, let's use the Pythagorean trig identity. Let's substitute 1 minus sine squared of x. But notice this, if you do the substitution, then after taking the square, you will have a term that is sine raised to the power of 4x. And this isn't any better. This didn't change the difficulty of the problem. And it even got more difficult because there are other terms as well. So no, this is not the substitution that we want to make. But what can we make? Think about it. We will use the double angle formula. That is, let me write it here. That is cosine 2x equals to cosine squared x minus 1. And in a previous video I proved this equation. You can find it from the cards right now and also from the descriptions part. Here I want to solve for cosine squared of x. When I do that, I will get that cosine squared of x equals cosine 2x plus 1 divided by 2. Now I will substitute this into our integral. We have the integral sign again. Now I write cosine 2x plus 1 over 2. This was cosine squared of x, so we also square it again, then dx. This will give us, now I see that I can take 1 over 2 out of the integral sign. It is a constant to leave us with cosine 2x plus 1 squared and then dx. Here I will just expand the parentheses. So we have 1 over 2 cosine squared 2x plus 2 cosine of 2x plus 1 dx, and let me put the integral sign. Alright, now we see cosine squared of 2x. What substitution should you make? I hope you didn't say 1 minus sine squared of 2x. You should again use this idea. This time instead of x, we have 2x. Well, that doesn't change it much. We will only do, so we will have 1 over 4, the integral sign. And instead of cosine squared of 2x, I will substitute cosine of 4x plus 1 divided by 2. Because as you can see from this equation, if I replace x by 2x, then this guy becomes cosine of 4x. And the rest is the same. We substituted that, plus we don't need to substitute for the others. They are pretty standard integrals. We have 2 cosine 2x plus 1 dx. Now we are ready to take this integral. This will give us 1 over 4 and the parentheses. What is the first integral? So maybe this part that you want to focus on. Which function, when taken the derivative of, would give cosine of 4x divided by 2? I would guess that it is something like sine of 4x. And I take the integral, I see that I have 4 cosine of 4x. I don't want that, so I divide by 8. And when you take the derivative now, you see that we get the part that is inside the red circle-ish shape. Plus 1 over 2, so I'm looking at this part right now. 1 over 2, that is just going to give us x over 2 plus, what about this guy? 2 times cosine of 2x. I would guess that we have something that has to do with sine of 2x. Let's take the derivative now. What is this? The derivative of sine of 2x? It is 2 times cosine of 2x. So that's it, in fact. We don't need to add anything further. Multiply by anything else. Then 1 will give us x. Here I see that this and this can be combined to give the result. Let me erase it. Actually, let me do it like this. Let me put a 3 here and get rid of this x. And let me make it cool. Like this. And this is the result, by the way. The derivative of cosine, the integral, the indefinite integral of cosine raised to the power of 4x is equal to. Oh, by the way, what did I forget? Look at this. What did I forget? Exactly. I forgot the plus c. Always add this. This is very important. So what was I saying? The integral of cosine raised to the power of 4x is equal to 1 over 4 times the quantity sine of 4x divided by 8 plus 3x divided by 2 plus sine of 2x plus c, the integration constant, which is super important. Anyways, this is it for this video. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.